I'd like to talk briefly about the difference between causal models and time series models. As I mentioned at the end of the last video, in revenue management, primarily time series models are used, and I want to talk just a little bit about why that is before we start looking at the individual models. So this is going to be a very quick review of causal models or regression models. These models look for the relationship between two or more variables and then use that relationship to make a prediction or make a forecast. So in the very simple example I've chosen here, we have high school GPA along the x-axis and then university GPA along the y-axis. And you can see from the scatter plot that there's a positive relationship. So the higher the high school GPA, the higher the university GPA. And the regression model chooses a line, this is a linear model, chooses a line that's the best fit among the dots on this graph. That line then gives us a coefficient that we can use as a predictor. So when we only have the high school GPA, we can apply that coefficient and make a prediction about what the university GPA is. Very simple, very intuitive kind of model. So if we were building a regression model for revenue management, what we would want to determine is what relationships drive demand for air travel. So you could think of those kind of variables, and I've just thought of a few here. Maybe higher income drives higher demand if the economy is doing well. So if GDP is high, there will be higher demand. Employment, either on the employment of an individual or the aggregate unemployment rate. Weather, so if it's cold in a certain city, that tends to drive travel to warmer cities. Maybe even the stock market, if people feel more wealthy because the stock market is doing well, they'll travel more. And I'm sure you can think of other variables as well. So if you were going to build this model, you would look for data that shows a correlation between the dependent variable, demand, and the independent variables. So could you find data that shows where when income is high, demand is high, or whatever the correlation is? When GDP changes, demand changes. When employment changes, demand changes. It would seem that this is a fairly straightforward exercise. I can tell you from my own experience having tried to do this, it's very difficult to find those relationships, and the relationships tend not to hold over time or with changes in other variables. So then you might say, well, what are those other variables? I'll just include all those variables. The more variables you include, the harder it is to get a good fit. The other thing that makes these models complicated is sometimes when you're making a forecast for revenue management, what you really want to know what the demand is going to be in the future, not just today based on the current conditions. So in a sense, you have to forecast what these independent variable values will be in the future when you're going to make a forecast. So there's sort of an independent problem that you have to solve is how do you get good data on these variables for current observations, and how do you predict what they're going to be in the future for when you want to make your forecast? Now, all that being said, they are still attractive models, and folks have tried to estimate these models and use them in revenue management. I've tried to do it. The fact is, at the end of the day, time series models tend to work better. And in a business application, what we care about is getting the best forecast, not how much science it's based on. So as you look through the literature of forecasting models for revenue management, you're going to tend to see time series models almost exclusively. Now there are customer choice models, discrete choice models, things like that, which we're really not going to get into. But the simplicity of the time series models and the reliability make them a good choice for an actual application, not a research project, but an actual application of a revenue management system. So let's take a look at time series models and how they work. Time series models are really simple models, and they're based entirely on past observations. So there's no variables. It's simply past observations of what you're trying to predict. So we're trying to predict demand for travel. So we're going to in a time series model, we'll take observations of demand from the past and apply trends or seasonality or other factors to use them to make a prediction for the future. So, for example, if we are trying to predict the number of customers who want to purchase a ticket to Orlando from New York next week, and it's 7 days from departure, we're going to look at a number of flights from New York to Orlando that have departed in the past and what the demand for those flights was a week prior to departure. And that's going to make up our forecast. So I have just a simple graph here. This is a very simple example of a time series model. And you can see I didn't even put the what the variables or what the axes represent, because it could be anything. And the key here is that whether it's months of the year or days or minutes or hours, time series model always follow a trend over some unit of time. In our case, this would be demand, and this would be, say, demand for a particular flight. And we would look at the historical data to come up with a curve like this. So let me show you what a real live example would be. In revenue management, the time series curves that we use are called booking profiles. And this is the history of flights and how they booked in the past. So for example, on the x-axis here, we have days prior to departure. And these graphs are kind of backwards. The time, and this is just by convention, so that's the way I'm going to do it. The time starts here and goes to 0 from right to left. So 360 is 360 days from departure. So almost a year prior to departure, when the flight first goes on sale, the bookings for that flight are going to start out at 0. So the booking profile always starts at 0. And as you get closer to departure, the bookings start to grow. And as you get closer and closer, of course, the flight will fill to its final demand, whether that's the capacity of the airplane or not. And these different profiles here are, in this case, they're different ticket price levels. So the demand isn't just for the a seat on an airplane, it's demand for a seat at a specific price. And I'll get into why these graphs are not all going to 0. So a time series model would look at these observations of actual demand, actual bookings, and use those observations to predict how a similar flight would behave in the future. These models could be as simple as additive models or multiplicative models. They could be something a little bit more sophisticated like exponential smoothing, but all of the time series models simply rely on past observations of demand to predict future demand. What gets a little bit tricky is, when I said before, you use this data to predict a similar flight in the future. So you can't use this booking profile for, let's say this was our New York to Orlando flight. You can't use a New York to Orlando historical booking profile to, say, predict demand for New York to Charlotte, because it's a very different market and the demand behavior is very different. So you have to figure out whether you're going to have a booking profile for every market, whether you're going to aggregate markets together to average out a booking profile. Those are all sort of implementation issues that we'll talk a little bit about later. One of the most important things that you have to get right when you're building these time series models is the seasonality. And seasonality could be the time of year, such as summer versus winter. So you can think that that's fairly obvious that in the summer there's going to be different types of demand to a destination than in the winter, based on the characteristics of that destination. It could be that in the winter time, A lot of folks want to go to a warm weather destination, but in the summertime, that demand for that destination may fall off because there's not the attractiveness of getting away from the cold weather. Other levels of seasonality can be much more granular. So day of week is a common level of seasonality that is used. So the demand for a flight on Friday is typically much different from the demand for a flight on Tuesday. It could be that Fridays are just more popular, or the other thing is the makeup, the characteristics of the passengers on a Friday flight tend to be different from a Tuesday flight. On Friday, you get vacationers going for a holiday for a weekend or starting their vacation. Tuesday tends to be more of a mix of maybe short travel, day trips, or business customers, or visiting friends. So those characteristics drive the demand pattern behavior, and they are usually separated out. The other thing is, if you get a little bit more granular, from day of week, you go to time of day. So maybe the demand for a flight at 6 a.m. is going to be very different from the demand for a flight at 5 p.m. So a system analyst might want to separate those two levels of seasonality. It could be morning versus afternoon versus evening. It could be hour by hour, 7, 8, 9, 10 a.m., having different profiles. These are all the things that have to go into the analysis before a time series model is implemented so that you get the best forecast. So you don't have to bother with correlations and estimating relationships, but using the historical data in the appropriate manner means everything to the accuracy of these models. And often what happens in real world applications is an airline will decide on a specific system to implement, and those time series models will require a certain amount of data in order to produce accurate forecasts, and the airline may not have that data. And then you have to make compromises. So maybe you don't have data at the day of week level, or you don't have it at the time of day level. The analysis of figuring out how to use the available data to warm up the models, to estimate the models, is a big part of implementing a revenue management system. And since these models don't rely on anything but the past data, the data is very important, of course, and is the only thing that will influence the accuracy of the forecast. So getting the data right, having good historical data, really means everything to these kinds of models. So in the next few videos, we're going to go through the different time series models. We're going to start out with the very, very simplest models, and we're going to work our way up to the little bit more sophisticated models like exponential smoothing. Then we're going to look at how these models use errors from the past. So if there was a prediction in the past and that prediction was wrong, how these models use the errors to actually update their models. So you can think of it as a model is using historical data to make future predictions. The accuracy of those forecasts is actually valuable data. So let's say you have a model that consistently over forecasts. It forecasts more demand than actually materializes. That's very valuable data, particularly if it's consistent, because then you can adjust your forecast. So if you're always off by 2 passengers, well then simply adjust your forecast to account for those 2 passengers, and you'll be more accurate. So the more sophisticated models don't really have a lot more math and science behind them, but they're better at using all of the available data, whether it's historical observations or the behavior of the model in the past, to adjust the forecast of the future. And those are the models that you tend to find in commercial revenue management systems, because they're trying to make the best use of the available data. So that's it for now. In the next video, we'll look at some sample data, how that data has to be organized, and then we'll apply it to a very, very simple time series model. Hope to see you there.